Okay, in our last video, we just finished going through the descriptive statistics for results section. Showed you how to do that. We got close to time, kind of rushed on time here at the end, and I want to make sure you're clear on how to interpret the correlation table. When you interpret a correlation, we're interested in the strength of the correlation, the direction of the correlation, and the significance of the correlation. So when we talk about strength, we're talking about a small, medium, or large correlation. So small is usually in absolute values. So these two right here, negative point 0.8, negative point 0.4 and point 0.4 would be interpreted both as being, in this case, moderate. So point 0.1, point 0.2 would be basically small, point 0.3, point 0.4 moderate, point 0.5 and above would typically be a fairly large correlation. We talk about the strength. So in this case, both of these are moderate correlations. The direction of the correlation, is it negative or positive? So the relationship between sex and prosocial behavior, we have a negative correlation, negative 0.49. When you're interpreting the correlation with a dichotomous variable, a categorical variable, you'd have to interpret it based on which group is coded 1 and 0. So here boys are coded 1, girls are coded 0. So as gender goes up, so to speak, it is with boys, prosocial behavior goes down. So in other words, boys have significantly lower levels of prosocial behavior than girls. That's what this means. This direction is positive, so it's a positive correlation. As we stated right here, as one goes up, the other goes up. Okay, and then also the level of significance. So you have the strength, the direction, and this level of statistical significance. So you take a look at the significance level, which is the middle number in each cell, and you're looking to see, is it less than 0.05, is it less than 0.01, or is it even less than 0.001? So both of these are less than 0.05. They're also both less than 0.01, but neither is less than 0.001. So if you had 000, we'd put p as less than 0.001. But in this case, they're only less than 0.01. All right. Okay, moving forward, checking the assumptions. So there's two assumptions we're going to check: homogeneity of variance and normally distributed residuals. In order to test these assumptions, we actually have to run the analysis with both independent variables in the model, and we save the predicted values and the unstandardized residuals as new variables. So you should remember this from the earlier lab on multiple regression a little bit back, but we'll go through it again here to make sure that you are clear on the concepts. So we're going to go to our data set. So we're going to run a multiple regression analysis. So analyze regression linear. Okay. Our dependent variable, and make sure you have these in the correct space. So once in a while someone will have their variables switched, and again your entire results section would be rejected because you have failed to actually test the research question you set out to test. So your outcome in my example is prosocial behavior, and my predictors are sex and peer church support. Typically you're going to put your categorical variables, these are demographic variables, in first in most cases. Not always, but typically. So we have sex, we have peer church support, predicting prosocial behavior. In order to test these assumptions, we need to save the predicted values. We'll go ahead and save the unstandardized predicted values and the unstandardized residuals. Okay, so we click continue and we click OK. So it's going to run this analysis. I'm not going to pay attention to it yet because you don't really want to interpret the results of your analysis unless you've tested the assumptions. If the assumptions have not been met, then your coefficients, the results, may be unreliable. Okay, so we have two new variables, the predicted values and the residuals. These have been generated for every single person in our data set, predicted values and the residuals. The predicted values is what their prosocial behavior score should be based on the model. The residual is the difference between that predicted value and the actual value. Okay, so here the predicted value is about negative 1.5. The actual value is about negative 3, so the residual is about 1.5, negative 1.5. That's the difference. Okay, so how do we check these assumptions? First, to test for homogeneity of variance, we're going to create a scatter plot with predicted values on the x and the residuals on the y. So we'll go to graph. Scatter plot still happens to be up. Predicted on the x, those are the residuals, predicted on the x, residuals on the y. So predicted on the x, residuals on the y. We'll go ahead and run that. We get this scatter plot. Very interesting. We'll copy that and we'll paste that into our lab report. Okay, so we need to interpret our scatter plot. What we want to know is the model equally predictive along all predicted values? So students who are children who are expecting to be high in prosocial behavior versus those who are supposed to have average levels versus those who we predict to have lower levels. We want to see if the residuals are approximately evenly distributed along all these values. So if we take a look here, there does appear to be a little bit of fanning. They look like they're a little more spread out here. So if you look at these three values on this end, they're boom, 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 right here, pretty close to the mean in terms of the residuals. We go on the low end, these three are very, very spread out. So there does appear to be some fanning, but we're looking for very, very gross violations. So it'd be a case where these are just all squished and packed together right on top of each other and then spread out like over here. That would be a problem. But as long as it's sort of approximately close, we'll go ahead and call that we'll go ahead and say that the variance is homogeneous. So our visual inspection of the scatter plot reveals that the residuals are approximately evenly distributed along all levels, along all predicted values. Okay, so what does that mean? It means that the model will be approximately equally predictive at all predicted values. Okay, thus the assumption of homogeneity of variance is supported. Okay, so in yours, as long as it's just sort of in the ballpark, we're going to say that it's supported. If you have a situation where they're really, really crunched together right on top of each other and spread out on the other end, then you'll note that the model won't be equally predictive, that the assumption is not supported. And in that case, we'll go ahead and move forward because it's a class assignment, but you'd want to be aware of that, and that could affect the interpretation of your results in an actual research situation. Okay, next assumption is normally distributed residuals. In order to check that, we're going to create a histogram of the residuals with a normal curve superimposed on top. So to do that, we go to Graph and Chart Builder and Histogram, and we want the residuals to be on the x-axis, nothing on the y-axis. We'll click Display Normal Curve and Apply. So up comes our histogram. I will copy that and paste that into the lab report. And here we are. Okay, so what we'll need to do is adjust this so they show up on the page together. There we go. So in order to determine whether the residuals were normally distributed, a histogram of the distribution was created. There we go. A visual inspection of the histogram revealed that. So again, we're going for approximation. It doesn't have to be exactly on the line, but we can see that it does approximate the normal curve, that the residuals were approximately normally distributed. Okay. Thus, the assumption of normally distributed residuals was supported. So again, we're watching out for something, just a gross violation. Maybe we have this bar over here on the right, and it trailed off this way, or big over here and trailing off that way. That would mean that we're systematically over or underestimating our predictions. Okay, so that does it for the assumptions. I will stop the video here, and then we'll wrap up with the actual analysis in the next video.